Hi everyone, welcome to another episode of here UmbrellaGeeks channel. Thank you so much one more time for all of you coming here to my video. I hope you all enjoyed the last previous video that we talk about networking and what you should know about your CCNA. And here in our second chapter, I'm gonna talk about switches and hops. And why this is important? Our second chapter is going to be switches and hops, and why I'm including this into our CCNA preparation, because it's part of the exam, and because if you are starting your career as a networking engineer, you have to know the two differences about these two incredible devices. So here we are, let's start. So firstly, when the internet and the whole networking already started let's talk about in the 1990s, or basically 1986, we were talking about hops, and hops was basically the first device that really existed during those times. But if we just go back and we go to the more or less 1940s, 1950s, yeah, there was hops over there were switches over there that basically they were the connectivity between telephones. And yes, they already existed, but they were not called switch, they were called commuters. And what were commuters means? Commuters basically, their principal job was basically to join one call to another call in different locations, so just basically acting like a bridge. Nowadays, and we go straight forward to the 1980s, if we go just right over there, we can find what is a hop. And a hop basically is just a bridge or a whole backplane when you could commute one line with another line through an internal line, and no one else was going to travel through that same channel. What was the meaning of that? So you got a whole hop, and you got different ports. You could commute one call with another call in one channel. No one else is gonna travel through it. But the bad thing was the whole backplane. Let's see, the whole backplane was 1 gigabyte. The whole 1 gigabyte was going to be divided to all the ports in it. The bad situation about hops, and one of the things that they experimented during the very early of the 90s, was that in hops, when you were sending one information, it was going to be repeated to all the ports available in the hops, even if those hops are not the ones who's supposed to receive the information. And here's I'm going to explain you how it works. Okay, so a hops works with MAC addresses. The hops doesn't have a MAC table, or doesn't manage the information with MAC tables, has the switches does. So the thing is, like, the hops, basically it's gonna do a broadcasting transmission. And what is a broadcasting? I had one message and I'm gonna repeat it to this port, this port, this port, and this port, all of them at the same time, till I find which is my destination. And destination will be, of course, included or already included in the MAC address of the framed header. So here's the thing, a hop, the bad thing of the hop is like there is too many retransmissions of the same message till it finds its own destination. And for that reason, hops didn't last too much time in our networking environment. And here is where switches come to the world. So switches. So the switch came to replace the hops and make the communication even better. And why? Because now switches, they can manage, they can control the information. What an incredible thing. There is a MAC table. Yes, and in this MAC table, not only have the capability to save the information over there, but also to classify the information by which port I supposed to send this information. For example, I have port 1. I received information through port 1, and suppose that my destination is supposed to be in the port 5. What is the meaning of that? That my frame, the switch, when the switch receives the first frame to the port 1, it's going to have the information that the other person is in port 5, or the other host is in the port 5. I'm not going to broadcast this information to the rest of the ports. I'm going to do it directly to the port 5. So in this way, it means that I'm saving. Firstly, I'm saving time. I'm saving the most important. I'm saving data. I'm saving speed, and everything is redistributed. But here's the thing, one of the main issues about this principal capabilities of the switch happened was like What happens if the frame is repeated in one of the older ports too? It could happen, right? So here's the thing. There is something called collisions detection. And what is the collisions detection? Basically, collisions detection is like if we have one port and I have another port, different ports, and both of them receive exactly the same frame. The first one who received the frame, that's the first one that was going to start the transmission. So we avoid this kind of collisions. In hops, this opportunity was not available, this feature. So it was introduced basically to the switches, and that helped a lot. Anyways, there's sometimes that we can receive the same frame in different ports at the same time. Who's gonna act over there? That's when we get another technologies advances in switches that they were made, of course, specifically for preventing those kind of issues. And then that was when VLANs appeared to the switch. So I'm going to talk about later about VLANs because I don't want to mix you into all of these situations. But before we proceed to VLANs, I want to talk about which kind of switches you should use in your environment before implementing it to your network. Firstly, we have to take care about cooling system, the size, the wave, and the money. Flexibility, and the band type of switch is going to bring to your company, which is pretty important. But before talking about the two types of switches that we can choose in our environment, let's talk about these three classifications that are going to be important for your CCNA exam. Here we go. Number one, layer 2 switch. And I don't want to talk about the seven OC layers because you should already know that. But if you want, I can make an entire video just talking about the 7 layers of the OC model. But here, the first model that we have is the layer 2 switch. A layer 2 switch is just a switch that has, it says, it just acts in the layer 2, it just receives the frame and works with MAC addresses. No routing procedure. Of course, you can manage VLANs in it, but nothing else. There's no routing procedure in it. That's the first. Second, that's the most common and regular type of switches that you can see in any enterprise. Number 2, we have the routing or layer 3 switch. A layer 3 switch, and how I said, it works with the TCP/IP layer from the TCP/IP model or the routing layer 3 model. What is the meaning of that? It means that if you want to send, let's say that you want to send a friend, and that friend is in another VLAN bed, or maybe is in another switch, and that your switch doesn't know that VLAN exists in the other switch, you have to have a middleman, and our middleman will be a router. But if you don't have a router with you, this capability is already included in your switch, so you can't have that functionality in your switch. But maybe people is telling me or is wondering about why don't use just simple a router and put a router on a stick with your switch. Yes, you can do that, but let's talk about that you can have all of those functionalities in the layer 3 switch. Which are the bad things about a layer 3 switch? Yes, because there is. The bad thing about a layer 3 switch is like your switch has to be the throughput of your switch must be so good or be resistible for being able to handle not only layer 2 traffic but also layer 3 traffic. And that happened in the reality. Later I'm going to explain you what happened to me with one of my experiences and one of my clients that happened. Like they get a Netgear switch, and this Netgear switch had a capability of routing and also being a layer 2 and layer 3 at the same time. But what happened was, like, suddenly they were experiencing some drops of connections. But I'm going to explain you what happened with that switch later. Here the point is, like, it has disadvantages of using the layer 3 switches, and because of that, people nowadays, they don't use it too much, and they prefer to use a layer 2 switch that can be manageable, and also, and with the help of a router, but external device, you can route your packets or your frames out of your switch. So number 3, the multi-layer switch. It's one of the most expensive switches that we can find because they control the traffic dependent of it is UDP traffic or TCP traffic. And what is the meaning of that? Yes, you can do quality of service you can do quality of service in your switch, and depending of if you're receiving data or if you're receiving also streaming information, you can classify the data, or you can classify the frame to go to a specific port, meaning that port can vary from speed, can vary from here it's broadcasting, what kind of broadcasting it is full duplex or half duplex, and that is the most important thing about multi-layer switches. The other thing that we have to take into account is the speeds and the duplex. Speeds and duplex, what is that? So basically we have, from the very beginning, we have the 10 base T, which is 10 megabits per second in a copper transmission, a copper cable. But that was pretty old, so people with the technologies and advances, we required more speed for our technology, because now we require more applications, and then we want to stream everything. We want to see real high quality videos in online in the website, and we really want those transmissions to be sold to be in a high quality transmission. So the thing is, like, we want to improve our speed, so that from 10 base T we improve to 100 base T. And what is 100 base T? It's 100 megabits per second of how Cisco recognizing it or know it has fast Ethernet channel. So yes, this is how Cisco recognized the 100 megabits per second in another technologies, but in Cisco they already know it has a fast Ethernet channel. So in a Cisco switch, you already know that a switch that it's classified, their ports are classified in fast Ethernet channel, and gigabit channel. So here's the thing: after 100 megabits per second, there was a time that engineers just decided like it was not enough for our applications and for the requirements up to date, that they decided that we have to improve our speed in the copper transmission. So they decided to improve it to 1 gigabit channel. And the thing is, like, yes, every time with the years now we have more and more speed, and we have to add it to our channel. But not only that, we also have to talk about broadcasting. We have to talk about duplex. And what is duplex thing? You have a channel, yes, but in that channel, like in any communication, we have two people for starting the communication. But the thing is, like, when you're talking by phone, you know that you are speaking and the other person maybe is speaking at the same time. So the information for not being cut or not being interrupted, the channel must be full duplex. What is the meaning of that? That you can talk, the other person can talk, but you can receive the information, that person can also receive the information at the same time. But there is another classification, and that is half duplex. Remember the walkie-talkies? Yes, I do, and you do. So walkie-talkies works like that, in half duplex. Half duplex, it gives you only the opportunity to talk in one way, but you cannot receive at the same time. It's exactly the same. At walkie-talkies, you just talk, send the transmission, then hear what the other person say, then you already give permission for the channel to transmit, then you one more time, they hang up, and then you proceed to transmit again. That's how it works. So we have full duplex, and then we have half duplex. Most of the time, half duplex doesn't work with 100 megabits per second. There are some depending on Cisco, the switch model. Of course, in Cisco, when we have a full duplex, the auto negotiation, that is something that I'm gonna talk later. The auto negotiation works with full duplex. It's already set up with fast Ethernet or 100 megabits per second. But I have seen many things outside there that they have 100 megabits per second with half duplex, which is terrible. I don't recommend it. For that reason, they have this auto negotiation feature, but I'm gonna explain it later in another video. I'm not gonna put too much information in this one, but I just wanted to know that before ending this video, that you have 3 types of switches: layer 2, layer 3, multi-layer switches, the difference between hops and switches, and also the difference in speeds, and what is duplex and what kind of duplex versions you can set up in your switch. I hope you guys all enjoy it. If you want to see more information, don't forget to comment below, give it a like, subscribe to my channel, and in the next video I'm going to talk about VLANs. So don't miss it out, and follow me on Instagram. Here it's my account. You can see most posts that I put over there regularly, and follow me. Thank you so much. Hope you enjoy it. Have a good day. Bye-bye.